Welcome to another math special video. And this time we have a geometry problem. What we are given is PQRS is a square, ABCD is a square, QXBY is a square, and ARY is an equilateral triangle. Okay, not a rectangle. It's an equilateral triangle. Okay. And we are also given that SR is equal to RA. This side is equal to this side. Okay. Then, if that's so, we must show that the area of square ABCD is twice the area of square PQRS. This is what we need to show. Okay. Now, how to do this? First of all, let's ignore this square and this square. Then what we have is, we have something like this, something like this. Okay. If I say this is A, then this is A. We have 90 degrees. This is Q, this is R, and this is A. Okay. Next, what we have is an equilateral triangle. Like this. Okay, this is an equilateral triangle. And we have a square like this. We have a square like this. We have a square like this. This was Q, this is A, this is Y, this is X, this is B, and we also have another line segment. This is AB. Okay. Now if we look at this, this is an equilateral triangle, so each angle of an equilateral triangle must be 60 degrees. This is 60 degrees, this is 60 degrees, and this is also 60 degrees. Now this angle plus this angle equals to 90. Since this is 60, this must be 30 degrees. Okay. Now let us look at triangle RQY. Triangle RQY. If we suppose we have RY is equal to RQ by given conditions, and so this angle is isosceles, and this is the base of the isosceles triangle. So this is theta and this is theta. Let's assume that these two angles are theta. Then twice theta, or should I say theta plus 30 degrees, theta plus theta equal to 30 plus 30 degrees is equal to 180 degrees. This means twice theta is equal to 180 degrees minus 30 degrees, which is equal to 150 degrees. Like this. So theta is equal to 150 over 2, which means 75 degrees. So theta is 75 degrees. This is 75 degrees. Okay. We don't need this angle, so I rubbed it out. This is 75 degrees. Okay. All right. Now, what we do is we join QA. We join QA. Okay. We join QA. Then what we have is a triangle. We have this triangle RQA. This is A, this is A, and since this is a right angle isosceles triangle, this must be 45 degrees. This must be 45 degrees. Now, let's see. This entire angle was 60 degrees. So this angle is 45 degrees and this angle is 15 degrees. Alright. And also the length AQ is A root 2 by Pythagoras theorem, root over of a square plus a square, which is equal to a root 2. Okay? Alright. Now this is 45 and this is also 45. Angle AQR is also 45, but this entire angle is 75 degrees. So what we have is that this angle was found to be 45 degrees. This is 45 degrees and this angle is 75 minus 45. This is 30 degrees. Okay, that's what we have. Okay, this is 30 degrees. Next, what you do is you join BQ. Now in a square, the diagonal bisects the angle at the vertex. So this is 45, this is 45. As a result, we have this angle as 45 degrees. This angle as 45 degrees. So now if we extend AY, this line AY, to meet BQ at some point O, then we have a triangle, right? We have a triangle here. We have a triangle like this, a triangle AQO. Okay? Now, angle AQO is equal to this angle plus this angle, means 30 degrees plus 45 degrees. This is 30 degrees plus 45 degrees, which means it is 75 degrees, and this angle is 15 degrees. Okay, 15 degrees. Now we can find this angle. Say, let's say this angle is, did we use alpha? No. Okay, let's say this angle is alpha. Then alpha plus 75 plus 15 is equal to 180 degrees. This is equal to 90 degrees. So therefore alpha is equal to 90 degrees. Hence, what we found is that this angle is 90 degrees. Okay, this angle is 90 degrees. Again, if you look at triangle QYB, this is perpendicular. This is equal to this side is equal to this side. This side is equal to this side. And by RHS rule, or should I say no need to use RHS rule, this is an isosceles triangle with this side equal to this side, QYB, with QY is equal to BY. So this is the vertex that contains the vertical angle, and from the vertex containing the vertical angle, we have dropped a perpendicular to the opposite side so that we have this length is equal to this length. So QO, this length, is equal to OB, this length. Now let us look at the big triangle BQA. BQA. This is 90 degrees and this is equal to this. We've obtained QO. Now we must note that AYO is a straight line. Why? We extended AY to meet BQ at O. That's why. Okay. Now this is Q, B, this is A. So now let's see. In a right angle triangle, in two right angle triangles, this side is equal to this side and this side is equal to itself. So these two triangles are congruent, this triangle and this triangle, they are congruent. Or we can say that this side is equal to itself, this side is equal to this side, and the angle between the included angles are also equal. So by SAS axiom, this triangle is congruent to this triangle, these two triangles are congruent, and so this side is equal to this side, like this. So this side is equal to this side. Now this side is AQ. AQ is equal to AB. AQ is equal to AB, and we already know that AQ is equal to A root 2. So AB is also equal to A root 2. Hence, what did we get is that in the original diagram, if we suppose this side is A, the side of side PQRS is A, then the side of this square is A root over of 2. Now, square ABCD is equal to 2 times, is equal to, its area is given by the side multiplied by itself. This is equal to root 2 squared means 2 and A squared means A squared. Now, square PQRS is equal to, what do we have? It's A squared, simply A squared. Now from 1 and 2, if we divide, since this is also positive, this is also positive, none of these are 0, none of these numbers, none of these, the area is positive, the side is positive, so no chance, there is no chance that these are zeros. Okay, so from 1 and 2, if we divide 1 by 2, we get square area of square ABCD by area of square PQRS is equal to 2A squared by A squared, which is equal to 2. That is, square ABCD is equal to 2 times of square PQRS, which was supposed to be proved. Okay, this is a question I found on Facebook. I'm going to put the link to the original post. I think it has also been solved in the post in the comment section. I don't know, I found this I don't remember. Okay, I'll just put the link in the description, and thank you for watching. Probably next math special video will be on ladder theorem. I won't guarantee, probably it will be on ladder theorem. Alright, thanks for watching.